lecture, we've been grammar of data wranglings. Okay, so there are certain packages that allows us to treat data like the way we subscribe or select variables or arrange variables or summarize and so forth into more or less like how we study a language. So for example, if you have a sentence, the sentence must have a subject, a verb, it must have some subject verb agreement and so forth. So that's the sort of thing that is done under this section, right? Okay. So there are packages that we need, okay, and the first one is the DPLYR. So if you don't have it, please make sure you install. If you have it already from your descriptive and inferential statistics, just load it like I have done. So please, you stop me any point in time if you have a question. So let's load it. If you don't have, just what do we call it? Install, so that you can have access to it. So let's quickly do that. Please, are you done with it?
That's it.
Good. Okay. All right. Okay. So there are actually 5 verbs that we'll be dealing with. So remember that I said the grammar is just like we are learning a language. Okay. So 5 verbs, what we call verbs, right? So the first one is select. So select is a verb, and what do we mean by this? So this takes a subset. Take a subset of the columns. And what is a column in a data set? Yes. If we have a data set, so for example, you have a corner. Okay, let's take a data set like the air quality, like this. The columns represent what? Please, let's talk so that it's interactive, not that I'm talking to myself. I've already displayed it, or you can't see what I have displayed. Hey, my dear friends. Variables, good. Okay.
Variables.
So when we say the select will take a subset of the columns, then it means you use this verb when you want to what? When you want to select what? Variables. Is everybody okay with this?
Yes.
Good. Okay, so that's the first one. Okay, next. So if we are able to select a variable, we should also be able to select what? Observations, right? So to select observations, we use filter. And that means here we are taking what? A subset of what? Of rows. Okay. So that's it. So we have a data set, we know how to select variables, we know how to select observations. The next is what we call mutate. And as the word means, it means it can change, right? Or develop itself into something else, right? Okay. So here, it helps us to add or modify existing columns. Okay. So sometimes you want to be able to what? Add a variable to a data set that is already done, okay, or you have it already in R. And that we can use mutate. Okay. Then we have what we call arrange. So arrange, to, as the name suggests, it means you can use it to what? Sort, so to speak. In the base R, we were using what? Order, or the function sort to do the same thing. Okay. And then lastly we have what? Summarize. So this allows us to what? Aggregate, do aggregation, get statistics and other computational stuff on a data set. So here we mean aggregate data, and it could be across the variables and so forth. Okay. All right. So now let's look at filter, select and filter. So let's also get this, the packages, tidyverse. So install packages. A tidyverse usually comes with the DPLYR. So the other one, MDSR. So this is the one you will not have. So let's install this MDSR, and then it means that I just need package MDSR. I have it already, so please load it. So actually you need library tidyverse. Yeah, but that's okay. So okay, now this is very important, what you have over here. Look at this filter. You see we have filter in DPLYR and then also filter in stats. So there are conflicts with this. So use conflicted package to force all conflicts to become errors. So it means that R is employing conflicted packages to get that. So this is something that can worry you, especially when you are working in it. So we will see. So for example, start. Usually, you see, I went to load tidyverse, and then because tidyverse DPLYR is already done, it functions in DPLYR, which is filter. It's also in start, but they perform different functions. So that's what we mean by a conflict. So now, if we will do it, if we get the error, then I'll correct it for you to see. So you have to always check when you do library of a package to see what if you have conflicts, right? It's very important. So tidyverse loads forecast, ggplot2 lubricate, pair, read out, string out, table, tidy R. So that's all, but it is telling you that it has conflicts with what? DPLYR and so forth. Okay, so there's a data set called presidential or presidential. So look at it. It's what? Data, let's all get it this way. Please check if you have it and you can display it on your screen. So it's a table which is just like a data frame that contains the name of the president of United States, the start and end date, and the party they belong to. So Democratic, Republican, and so forth. So 12 of them, including Trump. Do we all have it?
Yes,
Good.
sir.
Okay.
Yes.
All right. Good. So now let's start with the first one. Select. So let's assume that we want to select the name of the president and then the party they belong to. All I have to do is to call the name. So I'll do select. Then I start typing president. It will come, then I select. So you see, I don't wait for all of it to be selected, right? So I don't type up to the end. I just select so that you don't make mistake. Then I want to select the name. So if I like, I'll just come here and copy and paste so that I don't make mistakes. Okay. And then what else do I need? I want the party. So I select the party as well. Right. Okay. So this is it. Okay. And then I can run this. If I run this, it selects only the name and the party. Is everybody okay with this? So it's quite straightforward. Okay. Let's look at the air quality data we looked at. So let's get the wind, I think. So this one, these are some of the, let's say wind. Okay. Yeah, so it was right. The name air quality. I just want to get the names of the columns. Then there's ozone, right? So wind, ozone. So let me select ozone. So you can select as much as you want. Okay, and then I think there was temperature. That is temp. Okay, so I can select him. Okay, so this is it. I can name this as my A. All right. Okay, so if I name this, then it means my A is what? It's a subset of what? The um, you do remember head and tail? So I can do head of my A, and that will show me the first 6 observations. Okay. Or you have tail. Those are in the basal, right? Okay. But in GG plot, sorry, in the grammar of graphic, we have what we call glimpse. Okay. So glimpse gives you the columns and then it lists the values, and it will go as much as you have the enough space to um, show them. So if I, as I expand my this, it is showing me even more values. So please note the difference between head, tail, and the glimpse function. And even structure. So quickly run this, and then if you have any issue, you let me know. What do you want? Please, are you done? Can we continue? Please, you need to talk so that I will know what to do. Should we continue or you are still typing?
Continue, sir.
Okay, all right. So that's the select. Please, any question on select? Any question on select? Other than that, we move on to filter. So remember filter, we want to be able to select observations, right? Now, if you remember what we did in the basal, or wait, let me just scroll back and ask. So this is the grammar, or just using the grammar that we know. Now, how can you do this same thing in the basal? What we did earlier, this one, the selection. How can we do this in the basal? Quickly. Emmanuel. Emmanuel Tete. Hey, Emmanuel is gone. Yolanda. Hey, please, are you with me? Emmanuel, I was asking you, how would you perform that task if you were to use a Bazaar? Emmanuel and Yolanda, you must answer me. Please, are you there or you put on your Teams and you are somewhere? Yeah, Emmanuel, Etonam.
Sir, please, please, you, is it the dollar sign? We used that the last time.
Okay, so you said we should use the dollar sign. How?
The last time we called out the name of um the data frame, and then we put dollar there. We called out the column, the one with variable
Okay,
we're
so
interested in.
here we want two variables. So what are we going to do? Or here we
So
have three
presi
variables.
so presidential, then dollar,
Mm-hmm.
name.
Name. Then
Yes, sir.
what?
So, so the last time it was only one, but please, we can please try another dollar and then see what happens. And then party
We should try what?
another dollar and see. And I
Another
don't know the
dollar
last time.
again.
Yes,
Like
for them
this.
party. Yes, sir.
Hey, my friend.
The last time was only for two.
So now you have two. What do you do?
So please, I don't know.
Okay, you've done well with one. Yes. Who else? So whatever we are doing here can also be done in the Bazaar. Right? And you must know. That's why I started with the Bazaar. Christabel.
Hello, Doc.
Yes.
Doc, I'm not too sure.
Hey. Marianne. We started, I can scroll back and then we look at Seabine. This, so it means you've forgotten. Right? Right? So we've done subscripting. Is this part? The subscripting. So we said you can subscript with either the position or what? The names. Is that okay? So we've done this earlier. So this, we will select two. Do you remember? So if it is a data frame, all I have to do is to put what? A comma before this. Okay, so we've done this. It's not something that you've not seen before. So if we are, let's say, the air quality, I can call air quality, and then I put this dollar sign. Then I select the names that we want to do. We want to call like this. Put them in this, right? Okay, and then I select them. It's the same as what we got over here, up there. Okay, select. So my air and this are the same. If I look at it over here, the environment. Okay, so let me just clear everything. Okay. So let me select again my okay. Okay. So now I also do this. Let me call it my B, which is the basic R. Okay. Now, if you look at these two, they are the same, right? Okay. So you see, they are the same. Nothing really changes. Okay. So let's make sure that whatever we are doing, you can still have it done in the base R. It's very important. Okay. All right. Any question? I think they close it. Come and take. Please, any question? Okay. If you don't have any question, let's move on to filter.
Sir.
Yes.
So please, what's the difference? The base RN and this. So what we just did, what's the difference?
So the difference is that what we are doing now, as I said, it breaks whatever we do in the base R into components. And very soon you realize that we will be adding on, we will be talking about what we call pipe. When we do piping, we can do several things on the same thing. So when I take a data, I can select, let's say, some columns. When I finish, I can select some rows and do some computation, or I can select the rows and do some computations before I select columns, before I select rows, and so forth, all at a go. But in the base R, you can't do that. Yeah, so yeah, that's the modern way of using R is through the grammars, so that you put, and we'll talk about grammar of what we call it. In the case of the plots, we will also do a grammar, which is on the ggplot framework. Yeah.
Thank you, sir.
Right, okay. Or what we call grammar of data visualization. So now we are with the data wranglings. Okay. All right. So now we can move on to the filter. So filter is the same as what we did in the base R, where we are able to select rows. So for example, what if I want to select Republican president? What should I do? Well, in base R, okay, I can call presidential, right? And then I do this. I'm only going to select presidentials with party equal to Republicans. Do you remember this as well? You have to practice, and what we do in class is not just enough, right? So this, we've done some of them. Remember, this will give us all the party names. This, Republican, and this means I'm selecting only those who are Republicans. So if I run this up to here, I'm going to get true or false. It will be true if the party is Republican, and it will be false if the party is what? Democrat. So look at it. True. Then the next thing that I'm doing is that I'm passing these true to the presidential data, which means each row with true will be selected, and those with false will be discarded. So if I put this together and I run, you realize that every president here belongs to the Republican Party. Is everybody okay with this? So look at it carefully. We did this, okay, and that. If I were to select columns, I put it here. So look at this one. Before, you realize that this comes after the comma, right? This one is before the comma. Right. Okay. So that's it. So that's how you select columns, rows in the base R. Please, are we okay? Are we okay?
Yes, sir.
Okay. Now, what if we want to select Democrat? What should we do? Quickly, if we want.
Please, you change the Republican to Democrat.
Okay, we change the Republican to Democrat. That is one. What else?
Parties not equal to Republicans.
Good. How do we get a not equal to?
Equal to exclamation mark.
Which one comes first?
Equal to.
Are you sure?
Nation.
Let's do it. So you see, unexpected. There's the other way around. It comes before the equal to. There we go.
Yes, sir.
Okay. So that's it. But in the grammar framework, we are going to use filter. So we call filter, okay, and then the name, filter name of is presidential. Then all we have to do is to say that the party is equal to Republican. So I can copy it from here and say party is equal to Republican. So it's the same. If I want Democrat, I can also use a not equal to and Democrat. So that's the way the grammar works. Hey. You have to learn. Okay. Please, are we okay?
Yes, sir.
Good. Okay. Okay, so now I want us to also do something. So let's assume I want to select. So here, that's when you get to know the. So we want to select all Democratic presidents who ruled after 1973. So how do I do this? Well, we can do that in the base R. So now I'm not going to talk about the base R again. I want you to figure it out. So, but we are concentrating on the grammar. Okay, now, so there's a lubricate. This one deals with date, right? So in the grammar, there's a package called lubricate. Remember, just go here. It comes directly with the tidyverse family. So come to your packages and now look for lubricate. You realize that it has been ticked. It's lubricate, sorry, I said lubricate. So it's lubricate. So it's a data set it deals with what? It makes dealing with dates a little what? Easier. And so forth. So we are going to use this to help us select data setting which the data over what 1973. So how do we do this? Well, in here I'm going to put select and filter at the same time, because remember I want to select what? The president. Hey. Okay, so first of all I need selection to select. Okay, please, is everybody okay with what we want to do? We want to select Democratic president who ruled after 1973. Okay, the names is what we want to select. So we want to select the names. So whatever is there, after that I can talk about name. But what is left before then is that they should be Democrats and they should have ruled after 1973. So there are two things that we need to do there. Okay. So it means that those ones I need filter. I need filter to get the Democratic president like we have done up there. But there's another one which is that the end they should have ruled after 1973. Now what happens is that to deal with it we can use lubricate. Okay, so I'm going to make it simple. I'm going to do lubricate and delete it. So actually if you don't want to load the package, this is what you do. So lubricate, I can have year, okay, year like this, okay, and X, I click start. Okay, so not the start like this. Remember that this is what? Start date, right? So I'm giving it the start date, and the start date should be at least should be greater than 1973. Okay, so that's one part. And the party should be equal to what? Democrat. And so for that I can copy this and paste over there. So if I want just to be on the right side, I just copy this and say Democratic. But it could also be of this. So look, this alone can be done, right? Okay, so okay, let's see. Lubricate. Okay, let me take it off. I think there's a conflict somewhere. It should work. Let me do it again. Okay, so date, yeah, there should be, it should work now. Convert as positive. There's a conflict, but this should work. So DPLYR and load again. It still doesn't recognize it. There should be a conflict somewhere with the field. With filter start, package start. Okay, so my object start not found. Okay, then let me go back and do DPL. There's a problem with the low graded. It's strange. Low graded. And then again. So this is the problem that I was talking about with the masking. So what is happening is that one of these, it's masking it, and then I'm unable to get what I'm supposed to get. They should select the date alone. When you do year start, if you come here and okay, so no years, but year. Okay, so date must be in posits. Yes, and we have it like that. So year X, and that's the starting value. So a date time object. Yeah. Okay, let me do one more thing. Oh, this is okay. So don't let us waste time. I'll find out what is really causing the. But try at your end and let's see. Maybe I'm sure there's a conflict somewhere. But ideally, when you this works. Yeah, so function use method here, yeah. So lubricate, yeah. So if I put this together, I should be getting true or false for each of them, but error in they do not know how to convert S to something is wrong somewhere. Okay, let me do end date and see what will happen. We have end. Let me see. And let me take less than 1973 and see. Oh, sorry, it's there's no data. Sorry about that. Okay, so there should be, I need to call the presidential, yeah. Sorry, okay, so that's it. So now I can just run what is inside, yeah. Okay, so that's it. So it's I made a mistake. Sorry about that. And we've gone round. Yeah. So what this is giving us is that we've been able to now check days. We can't get it like this. That's what I was trying to do, and that was why I was getting the problem, because now it wouldn't know where the start is. But once I call the presidential, then the start is one of the columns, and that's why we're able to do so. Okay. Maybe I can try, but let me get this one out. And it means that I will need to bring the presidential ahead of it. Okay, so this would have to be presidential start like this. Okay, so this one, let's see, only this one. Yeah, okay, so this is what I wanted to show. Okay, so if I want to work on it like this, so true or false, so this is president whose year, hey, lower it please, I'm teaching. Okay, yeah, so you have all presidents starting 1973, and if we just look at the data, okay, president starting at least 1973 will be from here, right? Nixon, this, and so forth. Okay, so the first three will be what? Will be false. And so let's go and check. You see, the first three are false. Even the 1, 2, 3, 4. Let's see. Yeah. Sorry, it should start from here. 1974. So the first four are false, and that's true. Okay, 1, 2, 3, 4. The rest all started above 1973. They are all true. Okay. Now, the other part of it is which ones are Democrat. Well, if you look at it, the first one is a Republican, so that will be false. This is a Democrat, that will be true, and so forth. So if we also bring presidential here, okay, like this, right? Okay, if I run only this, what am I supposed to get? Well, so you see the first one is Republican, so we get false. The next one is Democrat, we get true, and so forth. So this is just to show you that we can actually combine, right? We can combine two. So those that are true, we are going to get what? True. I can line them up here, then you see what will happen. So this, you see we have true, then this one too, we have. So now if I put them together, we are only going to select where they are true, you get true. So look at the first one, false is false, true is false. We will only get true here, and you see over here is true, over here too is true, then you get true. The next one is here, true, and true. And then you have true, and true. So 3 of them. So if we do this, we are going to get 3, only 3 people, right? So let's come inside. Now that we know what these are, we can now go in there and select the names. And we are only going to get what? 3 names. And there it is. Okay. So basically, those are the names of the president whose terms, who are Democrats, and their terms are about 1973. Please, is this okay? So what we have done is that we've used selection that goes with the name, then the filter presidential, it goes with your date, starting date should be greater than 1973, and your party should be Democrat. Okay. We can add more if we want. Okay. We can add, let's say, we can add a party And we can even add the end date, right? So the name, end, and party, right? So that goes with the selection. So when we do this, it gives us the name, the end, and the party. And you see, if this is Democrat, we don't expect to see Republicans in there. So that's how you can combine these two to help address or do selection. Both at the variable section and also at the observation setting. Please, any question? So let's try and do this quickly, and then we can move on. So let's all try and type and see what is happening. And then, hey, Richard, are you?
Oh, yes.
Come and take a book. You pause it and then you do it.
Yeah, he has a paper.
So this, I can also leave it out because I have already, remember that the lubricate, we can take it out because we have already loaded it. So it's not really, but this is just to show you that you have what? It is coming from the lubricate package. So I can run it like this, I'll get the same thing because the package is loaded. Okay. Other than that, let me put it here so that when you get there, you know that you need the package lubricate. Okay. All right. Please, any question? So just to emphasize that the lubricate is to help us what? Work with dates. And dates include time, right? So when you go to you have as date, time, and so forth, milliseconds, daily, and so forth. So if you are somebody that at your workplace you deal with the data that is collected over time, this package will be of use to you. Okay, so that's it. All right. Please, any question? Okay, without any question, I now talk about piping. So what do we mean by piping in R? Well, so piping as part of the grammar of graphics, okay, helps us to work on so many things at the same time. Okay, so what we did, I'm now going to do it stepwise using the piping command. So we have what we call pipe, and pipe is this. So this is what we call pipe. There's a dollar sign with greater than, and then the dollar sign again. Okay. Now, what this means is that I take what is on my left hand side, I apply whatever is on my right hand side to it. Okay. So what we just did, I'm going to do it using the pipe framework. So I'll call presidential, I pipe it, then usually when you are doing it, you press it to the next level. Okay. Then I'm going to filter, so I'm not going to type, I'm just going to call this. But now I don't need the presidential again in the filter because I have already piped it. So like this. Okay. Right? Okay. So this, I can run only this one. and I'm going to get the results like this. Okay. Now, so the pipe, I can go on. So this one, it means that take presidential data, select those who are ruled after 1973 and are Democratic Party. So that has been given. Then remember we selected. What did we select? Name, end, and or party. So I can come on and also do my selection. Richard, lower it. Okay. Yes, like this. Then I select. And what am I selecting? This data set. Okay. So when I do this, you realize that the start date will not be part, right? Good. There it is. So this is what we mean by piping. Okay, so I can go on and on and on and on and on. Go and check if Moses is there.
No.
Yes,
But please, I don't really get the concept of the pipe.
the pipe. Okay, so you see, the pipe allows us to do things stepwise. You see, this one, I say select. Then I need to put everything with the filter in there. At each side, I'm always repeating the presidential. Okay. What the pipe does is that I can take this, do filter, select, I can arrange again. So I can go on and on and on and on and on. So I can go on again and say arrange. Okay. So I want to arrange them by, let's say, it's already been, okay, so let's say this descending name. Okay, so what I'm doing now is that you see now it has changed the arrangement. Check the other one. So pipe allows you to just be doing things stepwise. So you see the first one, Carter was the first one in terms of name. But now what I have done is that I have arranged their names in descending order. And of course it goes with their certain time of their presidency. No, the end time and then the party. Right. You see there? Okay. Please, is that okay?
Yes, yes. Thank you.
So from now on, this is what we will be doing. So we are not going to use select on its own and so forth. You always be using pipes to help you do certain things. Okay. Okay. So now, just let's see whether you understand this. So I want you to select. So select. Let try and let's see. Select presidents from the Republican. Who ruled before 1990. Let's see if you can do this. And then we want you to display the stats, the name, start and end date. Okay, so let's see. Oh, I just want someone to tell me how you do this. Then we move on since we don't have much time. Usually before you start, you must analyze and see, okay, this is how I'm going to do it. And then please, let's discuss. So, how are we going to do this? I mean, these are what you use to query data sets and so forth. So, it's important that you are able to understand whatever we are doing. So, we just did one. Let's just. Yes. Let's discuss. Nobody is wrong, nobody is right, all of it. Emmanuel, do you want to say something? Please go ahead.
Okay, sir, please. So we'll start with presidential,
Okay.
and then we'll pipe it.
Okay, so let's see.
And then,
Presidential. Okay. Then what?
Then we'll pipe it.
Okay, so we pipe.
We'll-
Yes.
In the next line, filter,
We filter. So I
and
select.
then
Mhm.
the year we can make the start less than 1990.
So I should copy this and make the start
Less than 1990.
less than. Awesome. 1990.
Yeah.
Okay. Yes.
And then we'll copy the end, the party, and make that Republican.
Okay. So this one we are going to just, because we know there are two, we are using this.
Yes.
Is everybody
Okay,
okay?
sir.
That this will also give us Republican.
Yes, sir.
Good. Okay. What else?
Yes, sir.
Then we pipe it again.
Good. Okay. Yes.
And on the next line, select.
We select. And then yes.
Name. Start and then end.
Please, is everybody okay with this? So there it is. We do this, and there we there. So it's quite. I mean, if you get to know how this is done, it's quite simple, and it's easier to treat data set with this sort of thing. Okay. Please, any question? Any question? Can we move on? Okay, so if we don't have any question, we move on to the third. Did I even name these ones? So let me name them A, or number them, I should say. So with this select, and then filter, where is filter? B. And then now we are going to see, unless, please, if you have any question, let's ask before we move on. So we are going to do mutate. Mutate. So in doing mutate, we are going to also add, there are several other verbs like rename as well. That can also help us. But let's mutate and rename. So let's add it to it. Okay. Please, so for the selection and filter, you now have the idea. You should be able to take any data and query yourself. How do I obtain this sort of subset from it, right? And some combinations. It's very important. You know how to do so. Okay. So now let's look at mutate. Remember that we said that mutate will add or modify an existing word, column or variable. Okay. So we can take any data set and then add anything to it, right? Okay. So let's assume that the presidential data set, we want to be able to get the, you remember it has start and end date, right? So we can actually get what? The length of years or days or whatever they rule. Okay. So that we can name it term length. So from what we have done, I can create a new let me call it my presidential. Okay. And this my presidential, I'm going to be able to construct a new, so this means that it will be, whatever we are doing will be assigned my presidential. So I take pipe, okay, and I'm going to use the lubricate function again, lubricate, sorry. So mutate, right? And then I'm going to add new thing which is called term length. Okay, term dot length, or when you want to attach things like this, you do it like something like that. Okay, so that people know, because you can't leave space, right? If you are leaving space, then it must be in quotation marks. So what you can do is term length or something like that, or term length. So what will be their term length? Well, the lubricate function allows us to use interval. So interval of dates. So it means that we have the start and the end date, right? But that alone will not give us what we want. So for example, if I do this and I go and check my presidential, you see the term length, it gives me a value like this, right? Okay, but I can convert this into a number. Okay, how do you do it? We can use what we call the D. So the D can be years, it can be month, and so forth. So D years. So they say lubricate. So it creates duration object. So we can use it to create the duration object. Let's say the x is equal to 1. Then I rerun this again. Now if I look at my presidential, you see it has now given us the term length in years. Okay, and so forth. So the lubricate function is package is a very important package, especially when you are dealing with date. Okay, when you work with time series and so forth, and you have this, it really helps. Okay, so this is D years. We can look at D month, okay, and so forth. And if we use D month, I can just copy this and paste and use and comment that this is term length in years. If I want in months, I'm going to change the D years to what? To months. To months. Okay. So D months. Okay. Okay. So now if I do this, I now have, you see, it computes it into what? Into months and so forth. Okay. So we can do dates and so forth, even times. Okay, so please do that and let's see. Let's all try and get it done. I am teaching during Easter. I'm teaching online. Happy Easter teaching. So yeah. How are you?
Okay.
When I finish, I'll call you in about an hour if you are not asleep. Okay. Thank you. Bye. Okay. So let's try quickly and do this. So when you get time, I mean, if you work with dates, please make sure you go through some of these things to know how they are done. So the D, if you come to the D years, D month, and so forth. So you see, you can also have D days, right? D hours, the duration in hours, duration in milliseconds, in minutes, in months, then in years, and so forth. Okay, so yeah, that's it. Please, can we move on? Please, can we move on? I'm waiting for you to give me the green light, so if we have to move on. If you are also facing difficulties, please let me know so we can address it. Please, are you done? Please speak up so that we can.
Yes, sir.
Okay, all right. Any question on this? So the key thing here is that you can actually what? Um, Add on to, remember the first time there was no term length over here. Okay. There are others that we can do. Okay. So for example, I can even add on to this, right? Let's say you remember sample. Do you remember sample? So we can sample. Okay, so let's say I can sample party. Okay, and then size is equal to, how many were they? 12, right? So 12. Okay. And then replace, we can say that true. So let's see, I want to add this to it and call it let's say M party and so forth. Okay, so what I'm trying to do is that it should take the party and then sample them of size 12 and replace is true, like it should yeah. So let me call this my precedent. Okay, so let's see what happens. Yes, okay, so let's look at this again. Okay, so you see, I can check whether you see that they are different, the M party and then the party. So this one, Republican, I still sampled Republican. This is Democrat. This was Democrat, but we sampled a Republican for it and so forth. So what I'm trying to say is that you can add on, right? You can add on to the mutate, okay? And you see we have term length and M party added to the original data set. So that's what mutate is. And is everybody okay with the use of the function sample? Okay, please, you can go ahead, Etonam.
So please, what is the meaning of the replace with T?
So that's replacement. So you see, when you are sampling, you can sample without replacement. So for example, in this class, let's say if you ask a question, you can't ask a question again, then it means we are not doing replacement. Okay, so I'm asking people like the way I ask you questions, and I'm doing it in such a way that, you remember I was calling your names randomly, but let's say if I call your name and I'm not going to call you again, then that's sampling without replacement. But if I call you and then in the subsequent questions, maybe the second time I can call you a second or third time, that means it is a sampling what with replacement. So that's what I was doing over there. Now, what makes this appropriate is that, well, I can also, instead of party, I can just use C, and then I copy Republican and Democrat. So like this, and then Democrat. Okay. Now, with this, I can still do the sampling. Okay. So what this means is that I have only two observation, Republican, Democrat, but I am sampling the, okay, so let me just put it here so that it makes it easier for you to understand before I put it in. I have only Republican and Democrat. If I do this, you have only Republican. How can you sample 12 things from it? Of course, it cannot be without replacement. Because if it is without replacement, I can only get 2. Right. But if it is replacement, it means when I pick you and you're a Democrat, I send the person back again and I can do this. So that's it. So that's what we mean by that one. And now, if I also click on this, I'll have this and it is still there. So that's sampling with replacement or without replacement. And usually, I mean, we use this in mimicking real life situations. Okay, so if let's say I want to remember your BMI index, so you want a sample to illustrate the function you wrote. Now, what is going to happen is that you could bring a weighing machine, okay, or a BMI machine to the class. Now we are not even there in class, but you can bring it in a class and then measure everybody's weight and height to help you illustrate your function. But that will be costly. You have to maybe go and hide the machine. You have to take a truck to bring it and so forth. Okay, what about us also mimicking what in real life? So that's what we call simulation. Well, so I can say, well, if I look at, let's say, the weight of people in this class, they may be between, let's say, 55 to 120. Okay, so if that's the case, then I can, let's say, simulate observations. Either I take a sample or I take a probability distribution. Then I'll say, well, you are randomly, uniformly distributed within the range 55 to 120. So I select 10 people from there, and then the height, maybe you'll be 1.5 to 2.2. I also select 10 observations from there. Then I use it to illustrate the function. So you see, in this case, I'm not going to the field, but I have created something that will mimic whatever is out there. And there, because 2 people can have the same weight, if I'm doing my selection, I must say that the replacement is what is true. So that's it. I hope this explains it.
Yes, so please, the T is
True.
The T
Yes.
stands for true.
Yeah.
Okay,
So it can
okay.
be true.
So
R can be true, or if it is F, is false. But it must be capital.
okay.
Yeah.
Okay.
All right.
Thank
You're
you.
welcome. All right. Okay. So that's it with mutate. Any question? Any question? So that's mutate. Okay.
So please, sir, when it is false,
Yes.
that means you can't repeat the same number again.
Good. Yes. So this one, you can't pick the same number again. So if I say false, this will be wrong because I cannot take 2 things and sample 12 from it if I'm not replacing. Do you understand?
Yes.
This will be an error. Yes. So it tells you cannot take a sample larger than the population. Do you get it? Unless you are doing replacement. It can't happen. So that's it. All right. Okay. Now, let's take this. I want us to use rename. So remember I talked about rename, right? So this one, I can take it back and say my president. Okay, and then rename. So let's say I have a variable in there, but I want to rename it. So for example, that we have term length, right? Let's see over here. Or let's say M party, and we want to replace it with sampled party. Okay, so all what I'll do is I'll rename to sample party is equal to what? M party. Okay, and then I run it. Okay. So now if I take my presidential, you realize that the M party has now changed to what? Sample party. And so forth. So that basically that's the rename. I have used arrange earlier, so you should be conversant with it. But let's look at arrange again. So let me ask you now, I want you to be able to arrange them, okay, according to the term length. So the one with the highest term length will come first. How should I do this? I did one earlier. Who can try? So the same piping, then we are going to arrange. But now I want it in descending order, which means the first one should be, so it means it will be your term length. Okay. So when I do this and I run, you realize that the first person 96, 96, 96, 96, then it comes to 66 and so. So this is in descending order. You can also arrange not just with one, but more than one observation. So for example, we can also arrange it by the sample party. So which means it will first arrange them in descending order, but it will also take into account what? The name of the sample party. So the 96, 96. So this one, if it's 96, they will be the same. But the next one, if it is arranging them, the Democrat will come first and the Republican, if there is a tie. If I want the Republicans to come first, then I need to also use what? The descending. Okay, so that's arrange. Please, any question? So these things, you need to practice them, otherwise you forget. Very.
Okay.
Yeah, do you want to ask a question?
No, sir.
Okay. All right, so let's move on to the next one, which is summarize. Okay, so this should have been D, right? And then E. Do you remember summarize? That is to help us what? Do aggregation, like analysis and so forth. Okay. So we are going to use summarize and also group by. Group underscore by. Okay. So now let's see. Let's take let's say air quality. So let's say we call it descriptive. So we take air quality and then we want to summarize. Okay, so N is equal to N. Let's see, so this will give us the sample size. So yes, so there are 153 observations and so forth. So then let's say ozone. It's assigned descriptive. Do you remember the site we have described, right? So let's let's start with, let's say, summary. I think we can use summary in this, right? So let's use describe. So let's first of all psych. Then it means I can call describe ozone. Yeah, ozone. Okay. All right. So yeah. So this is okay. Then maybe just to show you that we can have some others, like let's say, you remember coefficient of variation? We can call it as the mean of ozone, and then we divide by the standard deviation of ozone. Okay, so let's see whether we get there. Okay, so descriptive, there we go. So there are I made it what? It's what? Ozone. Okay. Instead of this, it should be let's say summary. Okay, so maybe summary statistics. Okay, so what I've done here is that I've done some statistics, but it will give you summary.this, summary.this, and so forth. Okay, what if I just, so I think it's better I just do describe. Let's see. Yeah, so this, it will just, yeah, better. Okay, so the first one is that we have 116. Do you remember that there were 153? So let me check the dimensions of air quality. (153). However, our sample size is 116, and it's because there are several NAs in the ozone. Okay, so that's the thing. So it's actually taking out the NAs. So let's say if you call air quality and you display the ozone, you should see, you see several, all these were NAs, missing values. So they were taken out, and then you are left with 111. Okay. So for the 116, the mean is 42, the standard deviation is 32, the median is 31, trimmed, mean absolute deviation, minimum is 1, maximum 168, range 167, skewness slightly positively skewed. The ketosis is 1. Okay, so that's the excess ketosis. So it is slightly longer than a normal. Okay, and then you have standard error of the mean is 3. The coefficient of variation is any. Who can help us? Why is it any? Why do you think we got any for the coefficient of variation? So describe actually takes care of the earnings, but mean and standard deviation unless you specify. So if I want to get this right, I have to come here and do na.rm should be equal to true, and then over here to na.rm should be equal to true. With this, I'll be in a position now to get the value. Oh, okay, it did not finish. Oh. There we go. So you see now it's 1.27. And it's true because you take the mean and then you divide by what? 32. So that certainly should be 1 point something. If you like, you can come here and multiply by 100 so that you express it in terms of what? Percentage. So 1.27%. Okay. So basically that's how summarize is done. So summarize allows us to be able to do what? Descriptive statistics we have in statistics, work on stuff, arrange, do this, and so forth. And so forth. Okay. Please get this done and then we do another example. And today is a holiday, so I don't want to get you too much. I want us to find out, okay, then describe group by to summarize. Now if you please, are you done with this? Finish this one and then we can add this and then that will be the end of our lecture. Please, are you done? Any questions? Are you encountering any difficulty? Okay. If you are not encountering any difficulty, remember here, we can even do test, right? Do you remember call.test? So let's see. I want to find the correlation between ozone and, let's say, what other one? Ozone. Let's see, air quality. Ozone and solar. So it is solar.r. So I can do so. No, it did not allow us to use core.test. Okay, within this, what if, let me see. What else can I even do? Okay, so let me see if test will work. Cool. Okay, yeah. So the test doesn't work, but we can find a correlation. It's also Na. So that you have to take out Na. Na.rm. It's true. Does the correlation take that? Let's see. No. Yeah. How do we take call? Let's see. Any call does not take. Okay. Yeah, there will be a way to do it, but it means I need to, I don't want to bother you with that, but one way to do it is that I have to now omit all, which is .na. Then you have to go to air quality. I'm recording it, so let me just do it. Don't worry yourself with it, and then Na, which is .na. So this will give me all there are about 33, 34, 35, 36, 37 observations which are Na. So I need to remove all of them from the ozone. It means that its counterpart in the solar will also be removed. And then also I have to do the same thing for whenever you encounter a problem, there will always be a way out if you know what you're about. This also, that one. Okay, so 5 overlaps, so it means that I'll have to I have to put this together, these two stuff together, then I use unique. So which means those that are duplicated, like 5 and 5 are Na. What again? 6, 11 is not the 27 and 27 are Na. So I won't let them repeat. I only choose one and so forth. So I can do this. Okay, I still need one more of this. So when I put them together like this, I'm going to get, so it means that when I take my ozone and solar, I'm going to delete all these values from it. Okay, so let's say I call it index. So don't worry, just look at me now and then removing NAs. You index NA. So when you watch a video, you can then do this. So it means that I can now copy this. Let me not even add it to this. So when I copy this one, I'll take out the na.rm, and then solar, I'll put negative of the IND. So that will take all the observations that are NAs from it, and then I'll get my value. There we go. So the correlation between it is 0.348. Okay, I can check that quite easily. If you bring it outside, if you bring it outside, it means you have to bring air quality in front of each of them, right? And then you can have it. Okay, so 0.348, which is the same as what we got over here. So this is just to illustrate to you that when you encounter a problem, you can still resolve it if you know how you have to go around it. So let me quickly add with group by and summarize. Now, remember that, for example, we looked at the anorexia data. I think mass is not there. Or even I think we've also looked at the auto BI, right? Is it auto BI? Yeah. So let's say you have library insurance and then the auto BI. Okay. Now, the auto BI, so let's look at glimpse so that you now look at some of the functions, the usage of these functions well. So glimpse, that's it. Seat belt, 1 or 2, okay. Those that are, so I may want statistics. If you remember this, we did describe by, or this and that one. So our X, usual described by data is equal to auto BI, and then we said X is equal to, let's say, loss. Okay, and then group is, let's say, sex or seatbelt. I think this doesn't work. We have to, yeah, so it's not recognizing this, even though we have the auto BI as this. But I can keep it over here like this. Then it means I don't even need the auto BI. I'll just take it off. So this will do descriptive statistics based on the seat belt. So here we can check whether those with seat belt incur more loss than those without seat belt. Okay, so seat belt, you see the average, they are in the majority, right? But their average losses are way smaller than those that do not wear the seat belt. And so these statistics we use described by in the basal. We can do the same thing in the grammar. Okay, when we get to the grammar, we can do the same thing. Okay, with this. Okay, so how do I do the same thing if I want to use the piping, right? What I'm going to do is that I'll take not air quality, so it's auto BI, right? And then I pipe. Okay, then I'm going to talk about group by, and what am I grouping by is a seat belt. Then I go to, I pipe again, and what do I want to do? Summarize. And what am I summarizing? Okay, I'm going to describe the loss. Okay, so whatever we go here, I can also get it through this piping command, and there we go. The good thing about this one is that it lists all of them, right, in there. Okay, and remember there are also those who the missing values are also calculated on its own. But if you look at this one, it's the same as what we did up there. So If you look at it, 1 and 2. So if you look at 2, you have what? 1, 22, 19.48 is assigned 19.5, 39, and so for the lastly, 8.31. There we go. Okay, so that's how you use the group by. So that groups them at the point. Okay, so basically that's it with the grammar of graphics. Oh, sorry, grammar of data structures. Yeah. I am only left with, I think, case when. You remember we did what do we call it? If I go back, this one. Okay, so your assignment, when you go, look at the what we mean by case when. Case when, case match. Okay, so but case when is a general vectorized if else. Okay, so this one also, instead of using if else, you can actually use case when, and this is the grammar stuff what you use instead of case. So you do case when this, do this, like that, and so forth. Other than that, you so instead of doing if else in DPL by R, they provide a function case when. Okay, so there it is. So for example, x is this case when x modulo 35 is 0 fixed bars. If case when is equal to 0 fixed, if you divide by this bars, the default is character x, and so forth. So you can look at some of these to understand what case when is. So Star Wars, select the mass, gender, species, then mutate, type, case when. If your height is greater than 0 and your mass is greater than 100, we say large. Species, if the species is droid, you now write as what? Robot. Other than that is what? Other. So by default is other. So this is what we mean by case when. We could have also used if. So if the condition will be that what? If height is greater than 200 or mass is greater than 200, you assign what? Large. Else, if species is equal to droid, you assign what? Robot. Else, other. So that's the same thing we did. Okay, so please go through case when and relate it to the if else we did. And that brings us to the end of our discussion on grammar of data wranglings. Please, any question? Any question? Okay, if you don't have any question, then we can end here. I'll send you the script that I use and they'll send you a link to YouTube for the video so that you can work on it. I will send you an assignment on data wranglings and up to what we have done to be submitted later on. All right. Okay. So enjoy the rest of your Easter and
Doc,
yes.
please. Yeah, we spoke about an assignment on classification. Yeah, so please wanted you to.
Oh, that was this. This one. Do you remember this assignment?
Yeah, I do.
Yeah, I said you should add classification so that it's just like, let me see. I made you search. We did BMI classification online like this. Okay, so you calculate you have your weight, height, and then the BMI, and then the program should now classify it as underweight, normal weight, or obese, and so forth. Yeah.
Okay,
Yeah.
sure.
So when you enter your weight and height, your function will calculate the BMI, and it will also classify it as either underweight, so and so and so. I say use the WHO criteria, which is so that's wrong. It should be less than 18.50. It's not greater than. So this is wrong. This is correct, but the one on the right is wrong. So below 18.5 is underweight, and then between 18.5 and 24.9 is normal weight. Of 25 overweight, and then above 30 obese. So basically, your function should input. It takes input height, weight. It outputs the height, weight, BMI value, and then the classification. That's it. It's just a simple exercise. Okay. All right. Any question again?
Sir, please, the BMI,
Yeah.
when you Google it, there are different
That's why I
criteria
said use the
and the
WHO.
different pictures come. Yeah, sometimes when we even put the WHO, so different pictures come.
Yeah, so choose
different
any of
criteria.
them. Usually it's the obese
All right.
that will classify it obese 1, 2, 3, something like that. But
Alright.
basically the normal
Okay.
ranges are the same. Just that you see different continents have different. So for example, if you take the Asians, they are quite smaller. That's why if you look at their own, the scale is a bit different. If you you compare yourself to a Chinese or a Japanese, you certainly will be larger than it. So if you use their scale, it will be like you are way obese or something like that. Yeah. So choose any of them, but the objective is just to know that you can classify and so forth. Not really the but the WHO one, whichever one you use is fine. Okay. All right. Okay. So I think that should be it for today.